Go. If we are required to find the antiderivative, and I'll put in brackets there, integrate, you need to be aware of the following symbols. So you've got that little squiggly, looks kind of like a loose S with A and B. Sometimes you'll have A and B there, sometimes you won't. A and B won't be A and B often, they'll be numbers. If there's no numbers there, your answer should be left with X's in it. And that's what we call an indefinite integral. And this probably makes absolutely no sense to you. So I'm about to go through an example. If there are values for A and B, we sub those points, the values for A and B, as start and end points. So whatever values you have for X, you'll sub in your B value, subtract whatever your A value is. We'll show you how to do that. This dx appears to be a problem for many Year 12 students on the way. Why can't we just integrate it without using the dx? The dx tells you what variable you're integrating. So you know we've got dy dx, that's saying what's the change of y with respect to x. When we integrate, we're undoing that, so it's almost like we're taking the dx to the other side. So that tells you that we're applying our rules to the x the entire time. Here's an example of what that would look like. This is actually a real world hypothetical scenario. Dropping an object. That function is a function for distance. If I want to know how far this object travels, I need to find the antiderivative or the integration. So the first step is we need to integrate that. What's the integral of that? The antiderivative of that. So what's the new power? X to the power of? Happy with that? Add 1 to the power, divided by the new power. And let's check if that works. How can we check if that works? Could we derive that? What would happen if we derive that? We should get that. Now I stuffed up my numbers so you can ignore the real world scenario, but that's okay. Doesn't matter. That's the integration. If that was an indefinite integral, if I had no numbers, that's done. That's my function completed. Let's say I wanted to find out how far this ball travelled between 0 and 2 seconds.